This is Learning and Memory, and I am teaching my roommate Becca. Say hi.
Hi.
And she's gonna learn a little bit about learning and memory. So, do you know anything right now about learning and memory? Anything about memory?
Like vaguely because of nursing.
Yeah. She's a nursing major, so maybe she'll learn some new things. I don't know. So, first, we're gonna start off with the multiple memory theory. Do you have any idea what that might be?
No.
Okay, so a multiple memory theory is that there are different neural structures for different parts of memory. So for long term and short term and like emotional memory, there's different parts of the brain that work for each parts. So, there's long term and short term, and then within long term, we have implicit, explicit, and emotional. And that's what I will be talking about today. So, explicit is conscious memory, so that has to do with like episodic memory, so it's like personal to you. So a lot of times it's stuff that you know about yourself, and it's also like facts and knowledge that you learn, which is semantic. And then that's explicit, and then implicit is non-conscious, so that's like your skills and your habits, like so things that you've learned, like walking, brushing your teeth, I guess, would be implicit. And then emotional is both implicit and explicit. And it has to do with, like, fear is a big one, like big emotions, basically. So, the next we'll go to a part of memory. I'm sure you know amnesia. Yeah, so amnesia is the loss of memory, which you should know as a nursing major. So there's two main kinds of amnesia. There's retrograde and anterograde. Do you know what either of those are? Okay, so retrograde. So once someone gets like a brain injury or something, retrograde is loss of the events before the injury. So like you wouldn't remember anything that happened before. And then anterograde is you would remember things before, but you wouldn't be able to form any new memories. Yeah, interesting. And there's a couple different types of amnesia. There's one that has to do with traumatic brain injuries. There's one that's infantile, so like child, and then there's like a fugue state, and there's one called Korsakoff. So traumatic brain injury is time-dependent retrograde amnesia, which is where you kind of forget the things that happened before the event, but you can still remember things like from the past. Like, you might forget like how you got into the accident, but you can remember what you did when you were 7.
Okay. So it's like long term.
Yeah. And then the severity determines how far back memories are impacted. So if you get like in a car accident, your head gets slammed or something, like that would be worse than like just getting like a concussion from falling or something if that were to cause amnesia. The amount of memory lost often lessens with time. So as time continues, your memory might start to come back and you can recall things more. And then for childhood amnesia, it's usually the inability to remember some things from the first 4 years of life. So, like, nobody really remembers things from when they were a baby. As the hippocampus continues to, like, form new synapses, new memories can be formed, and the old ones are disrupted. There's 2 more parts of amnesia. There's a fugue state and Korsakoff syndrome. So, a fugue state is kind of just, it's like a sudden thing. Like, you could randomly get it. I think we were talking about someone that you knew that had something where they just couldn't recall, like, a certain thing.
Maybe.
Like, so, I don't know. I think we talked about that.
Like they randomly forget like a specific thing, or they randomly have memory loss?
Yeah, like random memory loss. Yeah, so that would be like a fugue state.
Oh. Okay.
Yeah. And then Korsakoff syndrome, that's specific to alcohol use. So, with the use of alcohol, it can cause brain damage, which can impact the memory and also get false memories. So you may think that something else happened when in reality it was something else. So, yeah. Now we'll go into episodic memory and semantic memory. So this is where we're going to start to talk about like the brain structures. I have some pictures too that I'll show you that I drew for class. Episodic is once again like autobiographical, and it's like life events and history. So that is dependent on the medial temporal lobe. So in your brain, that's like right here and like in the middle. Okay. And the ventral prefrontal cortex. So that's also like, so your prefrontal cortex is in there and it's like down a little bit. Yeah. And they are connected by a pathway called the unicate fasciculus. Say that.
Unicate fasciculus.
Yep. That's with episodic memory. And then with semantic memory, it depends on the temporal lobes. So that's like right here, and the frontal lobes right there. In explicit memory, there's different structures that help to create the thing. So I have some pictures. So the first is the hippocampus. This is my picture of the hippocampus. And there's two gyri, I guess. So there's gyri and sulci in the brain. Gyri are the bumps.
Okay. So
there are two bumps. And there's one called Ammon's horn, and the other is dentate. So Ammon's horn is made up of pyramidal cells. So they're like little pyramids in the horn, in the hippocampus. Yep. And then dentate kind of reminds you of dental. So they're tooth-like, which is interesting. And those are stellate granule cells, so they're like stars.
Oh, fun.
Yeah. Connected to the rest of the brain by two pathways. There's the perforant, which connects the hippocampus to the posterior parietal cortex. The fimbria fornix connects the hippocampus to the thalamus. The two pathways, the perforant and the fimbria fornix, are connected. And it is important in retention right after learning. So right after you memorize something, the stuff that helps keep it in there are those two pathways. And damage to that anterograde memory is more affected than retrograde. So the ones where you're making new memories, that's lessened. Implicit memory structures, there's a couple more that we talk about. So there's the temporal cortex. So, and here and your right side, if it gets damaged, you have impairment of nonverbal tasks. And then the left is impaired verbal tasks. So
you could say, so right is nonverbal.
Mm-hmm.
RN for registered nurse.
Oh, okay.
And then L for verbal could be like left ventricle of the heart.
Okay.
I don't know if you'll remember that, but...
Damage to the parietal and occipital. So the parietal lobe, you have frontal, temporal, parietal, occipital. So parietal and occipital. So parietal is like movements and occipital is eyesight. There's a couple different things that it affects. So you could get color amnesia, which is where you like don't remember colors. Prosopagnosia, which is interesting. That's where you can't like remember people's faces or like what they look like. Object anomia, you can't name objects. So like if you looked at a plant, you'd be like, you wouldn't know what to call it. Topographic amnesia, you can't recall the location of an object. The frontal cortex, right here. The left prefrontal is more encoding, episodic, and semantic than retrieving it. So it's like coming up with things like, whenever I think of encoding, I think of like computer so it's like making things instead of retrieving. And then the right prefrontal is the retrieval part. That's all of explicit memory. Now we'll go into implicit memory. So implicit, again, is like your motor skills, your priming, recognition, and classical conditioning. So all the things that you like have learned that are not like about yourself or like history. It's independent from explicit memory, so it's like its own thing. And there's a couple different parts in implicit, you have the basal ganglia, which I do have a picture of. This is the whole basal ganglia. That's also another picture of it. And it sends info through the globus pallidus, right there, and the ventral thalamus. In the basal ganglia, if things are damaged, there's like two main diseases that can come from it. So you have Huntington's disease and Parkinson's. And with Huntington's, it's the degeneration of the basal ganglia. It really impacts implicit memory, but not explicit. And then Parkinson's, the dopaminergic cells, so like dopamine, of the brainstem to the basal ganglia die. They're dead. Sad. And they have trouble with implicit memory from that. But there's, you could take L-Dopa to help with that. Have you heard of L-Dopa? It's like the oral, like, taken form of dopamine. So it helps reverse it. And the cerebellum, I also have a picture of right there, the cerebellum. That is with the motor cortex. It receives projections through the thalamus from the cerebellum, and it's important in classical conditioning. And then the last part of the important memory structures for implicit is the neurotransmitter activating systems. So those all work together, and they're with the different neurotransmitters. So there's acetylcholine, which you would say is cholinergic, serotonin, which is serotonergic, noradrenaline, which is noradrenergic, and dopamine, which is dopaminergic. So with different losses in some of these things, different things can come about. So if you have a loss of just cholinergic, you can get amnesia and Alzheimer's. If there's a loss of both cholinergic and serotonergic, you can have profound amnesia with no intelligent behavior and also impaired learning. So that's implicit memory. And then this is emotional memory. So emotional memory is both implicit and explicit. It responds to stimuli with fear if there's a bad memory, but also it's not conscious, so it's like a non-conscious response. Within emotional memory, there's the amygdala that gets worked out, and it mediates fear conditioning, where the cerebellum would mediate classical conditioning. So that's a part of implicit, and then this is where the emotional stuff happens. And it is unique to emotional memory, so that's where it's all done. So that's all of long-term memory. And then short-term memory is basically your working memory, and that stores information for a short time only, hence its name. And it's either forgotten or it's transferred to long-term memory for storage. So it allows people to remember like lists of things for about 30 seconds, but then repeating it over and over in your head can help keep it there. There's two pathways. There's the ventral sensory pathway and the dorsal sensory pathway. So ventral would be more towards the bottom, and then ventral more towards the top. So the dorsal has to do with perception and motor movements, and then the ventral has to do with object recognition. That all happens in the prefrontal cortex. So Becca's results were, so the task was to measure nonverbal memory and visual short-term memory, and Becca got 100%. Her reaction time was 1.035 seconds. Okay, for the long-term portion, I asked Becca what she learned, specifically what the 3 parts of long-term memory are, and she got all of them right. She said implicit, explicit, and emotional. I couldn't really find a test online, so, most of the tests were kind of like that. But thank you for coming to my learning and memory.